Departure time 12 o'clock. Arrival time at 29 degree 29 minutes north 000 degree east. 14 hours 30 minutes LMT. Okay. Find ground speed. Okay. So ground speed. We have to calculate speed. Speed is nothing but what? Speed is nothing but distance divided by time. What is the distance? 500 nautical miles. What is the time? We have one time in UTC, the second time in LMT. So let's bring the LMT time at par with UTC time. Let's convert LMT into UTC. So arrival time at 29 degree north 000 degree east is 1430 LMT. Now let's say this is your Earth. We have the 00 degree prime meridian. All the timings at prime meridian are nothing but UTC timings, and also the time at this prime meridian, this particular longitude 0 degree will also be at the same time local mean time. So your 0 degree longitude is one unique longitude where local mean time equals to UTC time. So the place, your arrival, your destination is at 0 degree prime meridian. Okay. So 1430 LMT also means 1430 UTC. Okay, 1430 UTC. Now, what is the time between 12 hours? Time difference between 12 and 1430? It is 2 hours 30 minutes. So the flight time is equal to 2 hours 30 minutes, 2.5. So speed will be 500 divided by 2 hours 30 minutes, which is equal to 200 knots. 200 knots. Okay, so Bravo is the right answer. So you must know this concept of UTC time, LMT time. I have solved all the questions related to time, UTC, LMT from RK Bali, from Oxford, as well as from Keith Williams. So do watch that video lectures. Okay. Once you know this concept that time kept at 0 degree meridian is LMT as well as UTC, you will come to know that this 1430 LMT time is nothing but 1430 UTC time. Next. Type of altimeter that directly measures the distance to the ground below aircraft is called what? So that altimeter is called radio altimeter. So radio altimeter is that altimeter which will measure the vertical distance between your aircraft, okay, which will measure the vertical distance between your aircraft and and the ground below. This will be called height. This vertical distance will be called height. Okay, so radio altimeter. Now this barometric altimeter is nothing but your sensitive pressure altimeter, right? So whatever altimeter pressure setting you put in the setting window, according to that the vertical distance will be shown to you. If you put QNH, altitude will be indicated. If you put QFE, height will be indicated. If you enter standard pressure setting, pressure altitude will be indicated. Okay, so radio altimeter. The cockpit voice recorder and flight data recorder are designed to record data for specific duration of how much. So read this paragraph. Now, the requirements for the use of flight data recorder. So the first is flight data recorder in JAR certified aircraft is detailed for multi-engine turbine powered aircraft with 9 or more passenger seats. The requirements include the capability to record data for at least, for minimum, 25 hours for aircraft more than 5,700 kg, maximum takeoff mass, 10 hours for aircraft of 5,700 kg or less, maximum takeoff mass. So 25 hours for an aircraft which is heavier than 5,700 kg, 10 hours for that aircraft which is lighter than 5,700 kg. Now for cockpit voice recorder, the criteria is 2 hours for aircraft, 2 hours for aircraft which is heavier than 5,700 kg maximum takeoff mass, and 30 minutes for aircraft which is lighter than 5,700 kg. So 25 hours for flight data recorder, 2 hours for cockpit voice recorder. So the correct answer here is for cockpit voice recorder 2 hours, for flight data recorder it is 25 hours. So option A. Static vent gets blocked in unpressurized aircraft. The right action is to do what? So this is your, let's say, unpressurized aircraft. Now unpressurized aircraft, that means this aircraft will not be pressurized. The pressure outside this aircraft, the static pressure outside, will be equal to the static pressure inside the aircraft. Will be equal to the static pressure inside the aircraft, right? Now your altimeter, your VSI, your airspeed indicator works on static pressure. Now if this static pressure, which is static pressure port, which is located on your fuselage, gets blocked due to dirt, ice, dust, whatever, okay, whatever. So your instruments, your pressure instruments will not receive, your pressure instruments will not receive any static pressure input, any static pressure input, right? So if there is no static pressure input, so there will be no corresponding output, there will be no VSI indication, no speed indication, no ASI correction, no altimeter indication, right? So we must make some alternative provision for static pressure. Okay, we must look for some other way, we must look for solution. So if your static port is blocked or static vent is blocked, the next course of action will be to activate or to make use of alternate static source. If alternate static source is not available, you will break the glass of your vertical speed indicator. You will break the glass, the front glass of your vertical speed indicator. Now when you break the glass of your vertical speed indicator, what happens? All the static pressure inside your aircraft will enter this VSI instrument. Static pressure in your aircraft, inside your aircraft, will enter this VSI instrument, and when it enters VSI instrument, it will go in your altimeter. Okay, it will be used by your altimeter, that pressure, and it will be used by your ASI indicator. So now VSI indicator, although a significant equipment, it's not as important as altimeter and ASI. So it's always a safe option, a backup plan to break the glass of VSI indicator, because it is the least important of all the pressure instruments. When you break the glass, the static pressure in your cabin will enter the VSI instrument. That static pressure will go in the back of your instrument case, and that pressure can be used by all other pressure instruments. Question 86. The width of a stopway shall not be less than what? So let's say this is your runway. Okay. This is your runway. And this is your stopway. Now this stopway should be as wide as your runway. It should not be less than the width of your runway. Okay. It should be as wide as your runway. So a stopway is a defined area on the ground prepared for an aeroplane to take it, so it can be stopped in the case of an abandoned takeoff or aborted takeoff. So the surface of the stopway must be strong enough, must be robust enough to withstand that tremendous pressure of decelerating that aircraft and making it stop in one place. Okay, so the width shall not be less than the width of the clearway, width of the runway, width of the runway strip itself. So the correct answer is width of the runway. Next. The stopway surface must be capable of supporting dash. The safe operations at runways with displaced threshold, weight of aircraft without causing structural damage, initial climb to a specific height with adequate vertical clearance. So the stopway must be able to withstand the weight of aircraft without causing structural damage to aircraft or to itself. Okay. So option C belongs to your clearway. It's the clear way in which your aircraft will enter the initial climb mode and will achieve a specific height with adequate clearance between itself and the obstacles. Rate one turn at true airspeed of 250 knots. What is the bank angle required? So bank angle will be equal to true airspeed divided by 10 plus 7. So 250 divided by 10 plus 7 is 25 plus 7, that is 32 degrees. So you require a bank angle of 32 degrees if you want to make a standard rate turn of 3 degree per second at a true airspeed of 250 knots. Last question. Aircraft is approaching a station on radial 300 with 10 degrees starboard drift. Okay. It is asked to approach on radial 270. After reaching the station, aircraft is told to hold on radial 110. Non-standard hold. What will be the type of entry? So let's say this is your VOR station. This is the north data. Now let's draw all the radials in the question. Radial 300, reciprocal radial 120, radial 270, radial 110. Non-standard hold means left hand turns. Okay. Now you are currently approaching on radial 300 inbound. Okay, so that means your aircraft is approaching inbound or flying towards the station like this. Okay, and drift is 10 degrees starboard. So starboard drift, that means heading will be less than the track. So 10 degrees starboard drift, heading will be less than track. What is the inbound track? Inbound track is 120. So the heading of your aircraft will be less than 120 by 10 degrees, so 110. Okay, so let's draw this. Heading is aircraft is positioned on radial 300, heading 110. Now we want to make, we have to hold on, we are asked to hold on radial 110 left hand, non-standard hold. So, so that means your radial 110 will be your inbound course. Okay, radial 110 will be your inbound course towards the station. This will be your outbound course. So basically, your aircraft will fly towards this station inbound on radial 110, make a turn, left hand turn, then fly outbound, then fly outbound, then again make a left hand turn, and then again fly inbound. So this is your hold. Now you are approaching currently or towards the station on radial 300. You are told to approach the station on radial 270. You are told to approach the station on radial 270. Now when you approach this station from this side, from the west of it 270, and you want to enter this hold, how will you enter? So there are three types of entries. The first one is direct entry. Now direct entry is will be used if you are approaching this station from somewhere here, from somewhere here or here. Okay. So if let's say if you are approaching from somewhere here, so what will you do? Your course of action will be to fly directly to the station. Okay, to fly directly to the station and then start making left hand turns. Very easy. So just go direct to the station, make left hand turn. Okay. Let's say this is the direct entry. Second is teardrop entry. Teardrop. So what is the teardrop entry? It looks like a bubble like this. So if you are approaching the station from somewhere here like this, from northwest direction, which you would be doing if you which you would do if you were to approach the station from radial 300. So in that case, any aircraft coming from somewhere in the northwest, it will approach the station like this and then overfly this station I'm going to erase this, okay? And then overfly, it will overfly this station, okay, and then make a teardrop turn like this. Okay, so it will overfly the station, go outbound for some time, then make a left turn and then fly direct to that station. And once it goes direct to the station, it starts making left hand holding pattern like this. So aircraft is coming from here, overflies the station, and then makes a teardrop entry like this. Okay, so simple. So this is your teardrop entry. Next. Next is parallel entry. The parallel entry will be used by any aircraft which is coming from neither this direction nor this direction. So from any other direction like here, from anywhere here. So when you are coming from this direction, let's say this is your station. So this is your station and you are expected to make a left hand holding pattern like this. So when you come from any other direction like from west hand side of from somewhere here, southwest, you will fly direct to the station. Okay, towards that station, fly parallel to the inbound course. Okay, your inbound course is this. You're going to fly parallel to it but outbound. Once you fly outbound, you're going to make a turn and then approach the station like this and then start making a holding pattern, left hand holding pattern. So in this case, your aircraft is approaching from this direction. So it will be worthwhile to execute or to enter this holding pattern through a parallel entry. So your aircraft will fly to this station, then it will fly parallel like this, parallel to the inbound course, will fly parallel to the inbound course and then make a turn towards the station and then execute a holding pattern. Execute a holding pattern. Okay, so the correct answer here will be parallel entry. Offset entry is nothing but teardrop. Direct entry is nothing but coming directly to the station. Even if you are confused among these different options, you can start eliminating. So I eliminated direct entry. First things, step one, draw the diagram. Draw the VOR station, draw the node datum, draw all the radials given in the question. Determine the heading you are flying from and determine the quadrant you are in, whether you are to the northwest of the station, west, east, south, wherever. And when you look at the diagram, you will get an idea of how you are going to approach the station, what entry will help you to go directly to the station and make a left turn or right turn. So over here, we know that we are not coming from this sector, so direct entry eliminated. We are not coming from somewhere here. So again, teardrop entry is also eliminated. So the only option left is parallel entry. So select that. Okay. So that's it. So this concludes our lecture.